Good day, grade 8 learners. So in this module, you will be learning 3 lessons. Module 7, Rectangular Coordinate System. You will also be learning linear equations into variables and also how to get the slope of a line. Are you now ready? Let's proceed. Lesson 2, Linear Equations into Variables. What I need to know. At the end of the lesson, you are expected to define a linear equation into variables, illustrate linear equations into variables, and determine if an ordered pair is a solution of a given linear equation. What's in? Recall that a statement that says two algebraic expressions are equal is called an equation. The equal sign is used to denote equality. If an equation involves a variable, then a solution to the equation is a number that when substituted to the variable will make the equation true. When you were in grade 7, you have learned about that linear equations in one variable, such as 2x plus 1 is equal 9. So you have here an equation which has only one variable, which is x. You also learned that the solution of the equation is the value of the unknown x. That makes both sides of the equation equal. For example, so in the example 2x plus 1 is equal 9, the solution x is equal to 4. So how did we get it? So we have here 2x plus 1 is equal to 9, and our goal is to get the value of x. So in this case, we have to combine like terms. So we need to leave x at the left side and transfer 1 to the right side. So by using the additive inverse of positive 1, so we just have to add both sides with the additive inverse of positive 1. So we will get 2x is equal to 9 minus 1, or just simply transpose, in which since it is positive here at the left side, it will be, when it transferred to another side, it will now become negative. So that's why we have here 2x is equal to 9 minus 1. And it is equal to 2x is equal to 8. And to get the value of x, we have to divide both sides by 2. Therefore, and cancel those which we can cancel. So 2x divided by 2, you cancel 2, the remaining is x. And 8 divided by 2, it's equal to 4. Therefore, our value of x is equal to 4. So if we replace the constant 1 in the given equation 2x plus 1 equals 9 by another variable y, the equation becomes 2x plus y is equal to 9. And this equation is an example of a linear equations in two variables, x and y. Are you excited to learn more about linear equations in two variables? You will find out as you go through the lessons. Good luck! What's new? A linear equation in two variables is an equation that can be written in the form of ax plus by equals c, where a, b, and c are real numbers, but A and B cannot be both 0. So look at this equation, 2x minus 3 equals y. This can be written in the form of ax plus by equals c. So we can write 2x minus 3 equals y to 2x minus y equals 3. So we got here 2x as our ax and our by is our y. So it will now become negative y as we transpose y from the left side to the right. So since it's positive from the left, so as we from the right, so as we transpose it to the right, to the left, it will become negative. Same goes with negative 3. Since it is negative in the left side, so as we transpose it to the right, it will now become a positive. So that is positive 3. Again, 2x is our ax, negative y is our by. So our b there is 1, negative 1, and 3 is our c. And take note that a here is positive 2, our b is negative 1, and c is positive 3. So let's try to examine the following examples below. So let's check if we can write it in the form of ax plus by equals c. So we have here number 1, 10x plus 4y equals 3. Number 2, here negative x plus 5y is equal to 2. Number 3, y is equal to 2. Number 4, 2x minus 3y equals 6. Number 5, 4x plus 1 equals 9. And number 6 is x squared equals y plus 1. So let's check which among the following are linear equations into variables. So how will we be able to know if an equation is a linear equation into variables? So I'll give you time to think about which of the following are written in linear equations into variables. Think. Alright, so were you able to recognize which of these examples are said to be linear equations into variables? Can you identify? Yes, you are right. Only item numbers 1, 2, and 4 are linear equations into variables since they contain the x and y variables whose both exponent is 1, and a, b, and c are real numbers. Did you get it? So what made items number 3, 5, and 6 not a linear equation into variables? Let's find out. So for item number 3, y equals 2, it is not a linear equation into variable because there is only one variable being used, and that is only y. For number 5, we have 4x plus 1 equals 9. Again, there is also still only one variable used, and that is only x. And for number 6, we got here x squared is equal to y plus 1. So both x and y are used, so they have two variables, right? But x is raised to the second degree. So the exponent is 2, so it means this equation is quadratic, not linear. You will be able to know that it is linear if the exponent is only 1. And it is not written because we have learned according to the law of exponent that x to the power of 1 can also be written as x. That's why we don't have to emphasize the exponent 1. Alright, so is it clear now? So can you now give your own examples of linear equations in two variables? Alright, so afterwards, you may proceed by answering the activity that follows. Good luck! Alright, so you may try answering this activity. Activity 7.3. Shown below are sets of equations. List all that represents linear equations into variables. So we have here y is equal to 2x plus 1, x is equal to 3y plus 5, 1/2 x is equal to y plus 2, x squared plus y is equal to 7, 10 minus x is equal to y, y is equal to negative 6, 3x is equal to 4, 3x plus 4y equals 15, and y is equal to x cubed minus 1. So I believe you can just do it on your own. Good luck! What is it? So in this lesson, you will determine if a given ordered pair is a solution to a given linear equation or not. The solution of any linear equation into variables is an ordered pair that makes a true mathematical statement of the equation. Sometimes we are given an equation and one of the two coordinates in an ordered pair, and we are asked to find the other coordinates that makes the point satisfy the equation. So let's study the following examples. So we have here example 1, complete the following ordered pairs so that they satisfy the equation 4x plus y equals negative 1. So we have here A, blank 0, B, 2, blank. So we need to check if this coordinates in A and B satisfy this equation 4x plus y is equal to negative 1. So how are we going to do it? Let's find out. So we need to satisfy the equation 4x plus y is equal to negative 1. And in order to complete the coordinates blank 0, substitute the y value into the equation and solve for x. So we have here 4x plus y is equal to negative 1, and substitute the y value, which is equal to 0. So we will have 4x plus 0 is equal to negative 1. And let's simplify. So we will get 4x is equal to negative 1 and divide both sides by 4 to get the value of x. So we have here 4x divided by 4 is equal to negative 1 over 4. So cancel 4. So we will be able to get x is equal to negative 1/4. Therefore, the coordinates or the ordered pair is negative 1/4, 0. Now let's have B, 2 blank. So we need to find the value of y. So to find the value of y, we need to substitute the value x is equal to 2 and solve for y. So we have 4x plus y is equal to negative 1 and substitute the value of x. So we will have 4 times 2 plus y is equal to negative 1. And we will have 8 plus y is equal to negative 1. And add both sides by the additive inverse of 8. So we can just solve for the value of y. So we will have y is equal to negative 1 minus 8. Or simply y is equal to negative 9. Therefore, the ordered pair is 2 and negative 9. Now let's have example number 2. Let's determine if the given ordered pair is a solution to the linear equation 2x plus y is equal to negative 12. So we have the following ordered pairs, negative 2, 0, in A. B, we have negative 5 and negative 2. And C, we have there negative 12 and negative 14. Let's start with A. So let's check if the ordered pair negative 2 and 0 is the solution of the equation 2x plus y is equal to negative 12. So the first thing that we have to do is to substitute both x is equal to negative 2 and y is equal to 0 to the equation 2x plus y is equal to negative 12. So let's substitute. So we will be able to get 2 times negative 2 plus 0 is equal to negative 12. So the answer is negative 4 is not equal to negative 12. Since they are not equal to each other, therefore the ordered pair negative 2, 0 is not a solution since it is a false statement. So they have to be equal, so it will become a true statement. Now let's check if the ordered pair negative 5 and negative 2 will satisfy the equation 2x plus y is equal to negative 12. Now let's substitute first both x is equal to negative 5 and y is equal to negative 2 to the equation. So we will have 2x plus y is equal to negative 12, and substitute, we will have 2 times negative 5 plus negative 2 is equal to negative 12. So our goal is to have an equal number from the left at the left side and the right side. So now let's simplify. Negative 10 plus negative 2 is equal to negative 12. And the answer is negative 12 is equal to negative 12. And since they have the same answer at the left and the right, therefore, the ordered pair negative 5 and negative 2 is a solution since it makes a true mathematical statement. Now let's have C. So we have the ordered pair negative 12 and negative 14. And let's substitute both x is equal to negative 12 and y is equal to negative 14 to the equation 2x plus y is equal to negative 12. So we will have 2 times negative 12 plus negative 14 is equal to negative 12. And let's simplify. So 2 times negative 12 is equal to negative 24 plus negative 14 is equal to negative 12. And negative 24 plus negative 14 is equal to negative 38. And this is not equal to negative 12. Therefore, the ordered pair negative 12 and negative 14 is not a solution since it shows a false mathematical statement. So that's it for example 2. And that's how we solve linear equations into variables. And now, I believe you're now ready for our activity. What's more? Now, it's your turn. Activity 7.4. A. Write LE if the statement is a linear equation into variables, and NLE if it is not. Number 1. X squared minus y plus 1 is equal to 0. Number 2, 2x plus 3y is equal to 18. Number 3, 3y minus 4x is equal to 24. Number 4, y is equal to 1.75. Number 5, y is equal to x squared plus 2x plus 1. Number 6, x is equal to negative 10. Number 7, y is equal to x minus 5. Number 8, negative 4x plus 7 is equal to 2. Number 9, 5y minus 12 is equal to 3x. And number 10, x is equal to negative 2x plus 8. That's for A. Now we have a B. Complete the ordered pair so that each is a solution to the given linear equation. Number 1, 3x plus y is equal to 6. So we have the following ordered pairs or coordinates. 0, blank, blank, 0, 3, blank. Number 2, 6x plus 5y is equal to 30. We have here blank, 6, blank, 4, 5, blank. Number 3, y is equal to 1/2 x minus 1. So we have the first ordered pair, 2, blank. Second ordered pair, blank, -2. And the third ordered pair is -1, blank. Letter C, write yes if the given ordered pair will satisfy the given linear equation 6x minus 5y equals 1, and no if it will not. Number 1, -4, -5. Number 2, 1, 1. Number 3, 5, -2. Number 4, -1/5, 0. 5, -1/2, 1/2. So that's for letter C. That's it for our activity in our What's More. So good luck, and I know you can just do it. And take note that as you answer the activities in this lesson, you have to remember the following. Mathematical equation is a mathematical statement indicating that the two expressions are equal and using the symbol, the equal sign. So, linear equation in two variables. It is a mathematical statement with one as the highest exponent of its independent variable. Next, any linear equation in two variables can be written in the form of ax plus by equals c, where a, b, and c are real numbers and a and b are not both equal to 0. And the last one that you have to remember is solutions of linear equations. These are points in the coordinate plane whose ordered pairs satisfy the equality. So I hope you will remember those important points. So I'll end this lesson with a quote from William Paul Thurston: "Mathematics is not about numbers, equations, computations, or algorithms. It is about understanding." So that's all for this lesson, and I hope you learned something.